Hi and welcome back. In this video, we will discuss options to reduce energy demand for heating and cooling in buildings. You might remember this picture from the previous video. In cold climates, according to the laws of heat exchange, a substantial amount of energy is lost, or rather more precisely, escapes from buildings to heat the outside air. Energy mainly escapes through the walls, roof, floors, and windows of buildings. These are the so-called transmission losses. Therefore, if we want to reduce the energy demand for heating, we need to focus on reducing transmission losses. In this video, I will discuss an example for a building in a cold climate. In a warm climate, a large amount of energy enters the building and heats up the inside air, requiring energy to cool the building to a comfortable temperature. What you need to remember is that measures discussed in this video also help to keep buildings cool in a warm climate. Now let's go back to our home and discuss the most common options to reduce transmission losses including roof insulation, cavity wall insulation, floor insulation, and high efficiency windows like double and triple glazing. A wide range of options and material is being applied to insulate a building. But how can we compare the performance of different options and materials when it comes to reducing energy losses? You may have looked at the labels of insulation material and noticed a lot of different numbers and units to indicate the thermal properties. Thermal properties of materials are usually compared by looking into the U or R value. The U value equals the rate of heat transferred through a structure, which can be a single material or a composite, in watts, divided by the difference in temperature across that structure. The resulting unit of measurement is watt per square meter Kelvin. Next to the U value, you will also often see the R value, which is referring to the thermal resistance of a material or structure. There is a relationship between the U value and R value. They are mathematical reciprocals of each other. Thus, while lower U values indicate better insulation performance, higher R values indicate better thermal resistance. What you need to remember is that better insulated a building, the lower the transmission losses, implying lower U values or higher R values. This table provides an overview of U values for different materials used in buildings. For example, in the first 3 rows, you see the U values for an external wall, which shows a high U value for a non-insulated wall and lower values for an insulated wall. The bottom row shows U values for different types of glazings, from single glazing, double glazing to high performance glazing. What you need to remember is that more surface area, read a bigger building, allows more transmission, and thicker insulation leads to a lower U value. The ultimate impact of insulation on reducing energy losses in building depends on numerous factors, such as climate conditions, current insulation level of the building, size of the building, number of residents in the building, required indoor temperature level, and number of rooms heated. It is therefore hard to tell what the impact of insulation measures on reducing energy demands is, as this is very situation dependent. In order to get an indication on the impact of different insulation options, usually standardized situations are defined. This implies a standard number of occupants, indoor temperature, and climate conditions. To give you an idea about the expected impact of insulations, we take as an example a terrace house in our fictional city that is currently not insulated and consumes approximately 3,000 cubic meters of natural gas per year and has an annual gas bill of approximately 2,400 euros for space heating and hot water production. Now let's see if insulation can change this situation. We start with placing cavity wall insulation saving approximately €650 per year. Next, floor insulation is applied, followed by roof insulation, and finally HR++ glazing. The boxes show the investments, annual savings on the energy bill, and the payback time for each of the measures. It all sums up to a total package of approximately €12,000 and with annual savings of almost €1,900 generated by preventing of heating losses. This results in a new situation of a green home in which the family consumes about 750 cubic meters of natural gas and has an annual gas bill of €600. As already mentioned in the previous slide, we use a standardized situation to calculate the impact of different insulation measures. In models used to calculate energy saving potential and costs on, for example, a global, country, regional or city level, this is a good approach to get an impression of what can be achieved. However, you need to keep in mind that there can be a significant difference between the standardized situation and the situation for a specific household. Thank you for watching this video.